Right. So you can see the equivalent circuit and the paper, no? Hello. Can you hear me?
Yes, sir.
Yeah. Okay. So just give me an acknowledgement, right? Whenever, yeah, everything is okay, right? So you can see this one, right? So yeah, in our last class, we have seen how to draw this equivalent circuit, right? So without this RL and everything else, right? Without this one, and in our last class, we have seen how to draw this AC equivalent circuit. And now we are going to see how we can derive the equations for current gain, voltage gain, input impedance, and output impedance, right, of the circuit. Right, first of all, as I said earlier, see here, the green dotted line represents the transistor side, right? This HIE, HRE into V out, HFE into IB, 1 over HOE, everything comes inside the transistor, right? RC, RS, VS comes outside the transistor, right? So that's what I put a dotted line. So the current entering inside the transistor is IB, and the output current coming from the transistor is I out, right? So I have only RC, right? I have only RC, resistance RC. So I can write my V out as I out into RC, right? Similarly, I can write my V in, right? This is my transistor, right? This is my transistor. So I can simply yeah, this is completely removed, right? This is completely removed. I can mark this one, right? V in, which is, see here, the voltage across base and emitter, right? This is Vs, but this is V in. Why? We have an Rs here, right? So we can write my V in as V in equals, this current is IB, am I right? So IB into HIE, IB into HIE, right? This resistance HIE, IB. So plus HRE into V out, HRE into V out. Am I right? Similarly, of course, and then yes, I can write my I out as, right? I can write my I out as, right? See here, if this is I out and this is V out, right? This is V out, and then I can see that the voltage across this is V out. Am I right? So the voltage across this is V out. Hence, the current through the branch is V by R. Am I right? So V out by 1 over HOE, or that becomes V out into HOE. So this becomes V out into 1 over HOE, right? Sorry, V out by 1 over HOE, or V out into HOE plus HFE into IB, right? So I out will be V out divided by 1 over HOE, and that becomes into HOE plus HFE into IB. See here, we have equations with HIE, RE, OE, and HFE, right? So these are the parameters what we need here, right? So now, what is my current gain? Right now, I'll remove the circuit, right? So I have write down the equation so I can move away from the circuit. So my current gain is actually AI, right? Current gain is I out divided by, what is my input current? IB, right? The current through the loop is same. There are no parallel loops. So if I take it as IB, the current through this is also IB, right? So my current gain will be I out over IP. Look at here, this is my equation, right? This is my equation for I out. So I can write it as I out is equal to HFE into IB plus HOE into B out. Am I right? HOE into V out. Right? So now I can substitute V out as RC into I out. Am I right? So I can rewrite this equation as HFE into IB plus HOE into RC into I out. Am I right? HOE into RC into I out. Again, sorry, this becomes minus, right? There is a minus, right? There is a minus since the current is going inside. So this becomes minus HOE into RC. Am I right? So I can bring I out one side and IB one side, IB the other side, right? So I can write it as, right? So this one is, I have an I out here, another I out, right? So I can write it as, just bring this one the other side, right? So HFE into IB, right, equals minus of, right, 1 plus HOE, right, into RC, right, RC into I out, right? This I out will go there, will become minus 1, and then I have HOE RC I out. So I took I out common, so this becomes something like this. So my gain is actually I out by IB, right? So I will take I out, this IB there, and this one here, right? So I out by IB equals minus HFE divided by 1 plus HOE into RC. Clear? So this is my current gain. Right? If you know the values of HFE, HOE, RC, just substitute them and you will get the answer. Right? So this is how get the current gain of a of an AC equivalent circuit of a transistor, right? Sorry. Right. Now we'll move it into input impedance, right? So always, whenever you are deriving the parameters, just follow the same order as I am doing, right? So first I have done for the current gain. Right now I am deriving it for input impedance. Right, impedance, sorry, impedance, right? So input impedance is actually Z in, right, which is given by V in divided by I in, right? So V in divided by I in will be your Z in, right? So from this equation, what is your V in? Right, so I'll rewrite this one, right? So from the equations, you have derived that, or you have obtained that your V in is equal to HIE into IB, right? So in this circuit, I in becomes IB, right? I in becomes IB. So in this circuit, your Z in becomes V in by IB, right? So I'll write it as, sorry, HIE, sorry, into IB plus HRE into V out, Am I right? HRE into V out. Clear, right? What now? What I can do is simply I am going to divide everything by IB, right? So I am going to divide everything by IB. So just assume that IB, IB, right? IB, and also I can write my V out as, see here, what is my V out? Minus RC into minus RC into I out. Clear? So I can write this as, right, instead of V out minus RC into I out. Am I right? So now IB will get cancelled. V in over IB becomes Z in equals HIE plus, what is I out over IB? What is I out over IB? Your current gain, right? AI. Your current gain. So I can write it as HIE. It's not plus. There will be a minus, right? HRE into, right? Oh sorry. RC into RC into V out, right? Yes, sorry. HRE into RC into AI. Am I right? HRE into RC into AI. So I can rewrite this as HIE, and from the equation, right, from the equation, I am going to write the whole thing, right? So minus into minus becomes plus, right? So minus into minus becomes plus, and then I can simply substitute that HFE, HRE, RC divided by 1 plus HOE RC. Am I right? So this is your input impedance set in. Clear? Your input impedance is that in, right? So see here, if you follow the same order, you can use your AI in your Z in, right? So simply by dividing it, you can get the answer, right? So don't mix it up, right? Just go follow the same order, right? And then now we'll see the third one is V out, sorry, A out, A V, which is your voltage gain. Right from the circuit, I can write my voltage gain as V out divided by V in. Right? V out divided by V in. So I can rewrite this equation as, right? So V out is actually minus I out into RC. Am I right? Divided by V in, right? So instead of putting, okay, V in, right? So what I can do is I'm going to multiply I in by I in, right? There are no changes, right? What I'm going to do is I in by I in. So what I can do is I can shift interchange this one. I'll bring this one there, that one here. So simply I can write it as minus I out into RC divided by I in into I in by V in, right? So what is I out by I in? What is I out by I in? Will be your current gain, right? Minus AI into RC. And what is I in by V in? Sir, sir, sorry. Right? So What is I in by V in? Your V in by I in is Z in, right? So I in by V in becomes 1 over Z in. Am I right? It becomes 1 over Z in. So I can write my voltage gain as, right? So AV equals minus, sorry, AI by Z in into RC. Right? AI by Z in into RC. Remember, you are using both AI and Z in the voltage gain calculation. Right? So don't just mess it up. Right? If you follow the same order, you can do it easily. Right? The final one is we are going to do the output impedance. Right, output impedance. To draw the so to derive the output impedance, what we need to do is we need to do a change in our circuit. Actually, from the definitions, V out is actually Z out, right? Z in is input impedance, Z out is output impedance, right? So Z out is actually V out at Z out equals infinity, right? Which means this is your RC, right? Or the output voltage. You need to make it open circuit. This should be infinity, right? You need to open circuit this one, right? So the voltage is actually V out is actually when you open circuit this one, right? And also divided by I out when, right, Z out is equal to 0, right? I out equals when, which means you need to short circuit this one and the current through this one, right? So whenever you short circuit this one, this will be removed, so all the current will be going through it. So I can write that I out at RC equals 0 equals minus HFE into IB. Am I right? HFE into IB. The whole current is going to go through that one. Right? And then what we need to do is V out. Oh, sorry. I think we need to change this one, right? Okay, so stop this one, right? So we can, I'll do the open output impedance. No, we can do it, don't worry. We can do it now. Right? Okay, so the output impedance calculation is completely different from all the other three derivations, right? So we have done sorry, the current gain, then Z in, and then voltage gain. Now we are moving to the output impedance, right? So Z out. Right. To measure the Z out, you need to redraw the circuit again. Right? You need to redraw the circuit again. To measure the Z out, first of all, what you have to do is you need to short circuit the input supply, right? Short circuit the input power supply. So I can simply draw the circuit something like this, right? So this will be my HIE. This is HRE into V out, right? This is plus minus, and then here I'm going to have my RS. Clear, right? Similarly, at the output, I need to open circuit the current, right? I need to open circuit it, right? So 1 over HOE HFE into, let this be I, right? Small I, right? This is not IB anymore, right? So we have used a different notation. So if this is I, then this becomes HFE into I, right? This becomes HFE into I, and then the output impedance is open circuited. You need to short circuit the input, and then the output must be open circuited, right? Now we need to apply Kirchhoff's voltage law, right? Kirchhoff's voltage law in this loop, right? So if I put I in this direction, see here plus minus, so there will be a minus, right? So I can write it as I into RS plus HIE is equal to minus HRE into V out. Let this be, okay, make a different notation, right? We used as HIE and this as, okay, make it VO, right? VO, right? HRE into VO. So I can write that I equals, right, minus HRE into VO divided by RS plus sorry guys, HIE. Okay, this becomes my I. And now apply the same in the output loop, right? In the output loop. So I can write my I as, right? I can write my I as, if the voltage across this is VO, right? If the voltage across this is VO, then the current through this branch is again 1 VO by 1 over HOE, which becomes HOE into VO. And let this be current IO, right? So these two currents are going to be added together. Am I right? So that becomes, right? So IO is equal to HFE into I plus VO into HOE. Am I right? VO into HOE, right? So this is my whole equation, right? So I can write I, this one, right? Instead of I can substitute this one. Am I right? So I can write it as IO equals minus HRE HFE into VO divided by RS plus HIE plus HOE into VO. Am I right? I can take VO common and then bring it to the other side, right? So I can write it as IO by VO equals, right? So these two common, and then HOE minus, right? HOE minus the whole term. So E minus the HRE HFE divided by RS plus HIE. Right, so what is my I naught by V naught, IO by VO? Actually, my Z out equals, right, VO by IO, right? This is IO by VO, so I need to turn this one upside down. So I can take this one as the LCM, so I can write my VO by IO, which is my Z out, right? Which is my Z out is equal to, right, this will be on top, RS plus HIE divided by, right, so this into this becomes here, right, HOE into RS plus HIE minus this term, right, HRE into HFE. Right, so this is my output impedance. Right, so that's all about the derivation of all four parameters of a common emitter amplifier. Right, now look at your circuit. Right, look at your circuit. We consider this as V in, am I right? Why? That is the voltage applied across the transistor. Right, we consider this as V in. But we have Vs as well. We have Vs as well. So we can calculate the overall voltage gain as well. Right? We can calculate the overall voltage gain, which is A Vs, right? We can mark it as AVS, which can be defined by V out divided by Vs. Right, V out divided by Vs. I can rewrite this one as V out divided by V in into V in divided by Vs. Am I right? So V in get cancelled. So that will be V out by Vs, which is this one, right? So V out by V in we have already calculated, right? What is that? Your voltage gain, right? V out by V in you have already calculated, right? So what is that? Yeah, this one, right? AV equals AI by Z in into RC, right? So here V out, sorry, that is one, no, yeah. Here V out by V in, which is my AV, so I can write it as AV into hello. 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 Oops. Okay. Right. So my AV into V in by Vs. Right. What is V in by Vs? Look at here. You can assume that this as a simple potential divider. Right. So I can redraw this circuit as, right. So this will be my Rs, and then the total resistance between these two terminals becomes Z in, right? So this will be Z in, and then I connect it to Vs, right? So this becomes again a simple potential divider. This is my V in, am I right? This is my V in, right? So Rs is Z in, right? So I can write V in as, right? So I can write V in as, right? Z in divided by Rs plus Z in into Vs, right? R in into, so I can write my V in by Vs as Z in by Rs plus Z in, right? So this becomes this one, right? So I can write this one as AV into Z in divided by Z in plus Rs, right? So this is my AVS, right? Okay, so that's the derivation, and I will upload couple of tutorial questions for you, right? So that is the derivation for common emitter transistor amplifier. Okay, common emitter transistor amplifier. This is the hybrid model derivation for a common emitter transistor amplifier. Yeah, it's 9:11:40. Yeah, we have time, right? So we can continue with the common collector circuit as well. Right. So now let's see how we can do hybrid equivalent circuit of a common collector transistor amplifier, right? Do you, anybody have class at 12 o'clock today? Any of you have classes at 12 o'clock? Nobody. Okay. Right. So now let's see a common collector transistor amplifier. Right. So I'll draw a common collector transistor amplifier first, right? So this will be directly, right? Of course, there will be capacitors, Vs, Rs, R1, R2, Re, and then I will have my output across the emitter terminal, right? This will be V, right? CC. This is DC voltage, and this will be my V out. This is grounded, right? This is grounded. So Vs, V out, VCC, R1, R2, right? So this is my common collector circuit. Now I am going to draw the equivalent circuit first, right? I am going to draw the equivalent circuit. Right. First of all, I'll draw the equivalent circuit of a BJT first, right? Right. I'll draw the equivalent circuit of a transistor, which is right. This is the equivalent circuit. So, right, this will be my emitter, collector, and this will be my base. Right, this is my HIC. Right, since it is common collector, the parameters are HIC and plus minus HRC into V out. This is HFC into IB, where the current is the actually the current entering to the transistor, right? This is IB, right? HFE into IB. This is 1 over HOC, right? So this is my collector, emitter, and now look at this circuit. Look at this circuit. So this is my collector, this is my base, and this is my emitter. Collector is directly connected to VCC. Am I right? So well, the first thing I have to do is I need to short circuit all the capacitors, right? I will have a C in and C out. I have to short circuit all the capacitor. This will be short circuited and C in will also be short circuited. Next thing is I need to ground all the DC voltages, right? I need to ground all the DC voltages. So see, VCC is grounded. So see here, collector is directly connected to VCC and now it is grounded. So I can put, right, is grounded, right? Collector is grounded. And then look at here from base to, okay, let's make it as R1 and this as R2, right? The top one as R1 and the bottom one is R2, right? So from base to R1 and that is also grounded, right? If VCC is grounded, this one is also grounded, right? So from base to R1 and that is also grounded, right? Again, see here from base to ground, remember, right? From base to, I have R2, which is also grounded. Am I right? Which is also grounded. And then look at here, from emitter to RE and grounded, right? This is my emitter. So I have RE and then grounded. This is my RE and my V out is actually across RE, right? My V out is actually across the emitter resistance RE. This is my V out. Clear. So this is my whole circuit, right? This is my whole circuit. So this is grounded and then, oh sorry, I forgot this one, right? So this one RS and VS that is connected to ground, right? So this one, right? So I have my, sorry, RS and VS and that is connected to ground, so I can connect all the grounds together, right? So I can make all the grounds together, right? So this ground, this ground, this ground, of course. Now look at here, this is ground, right? So I can simply fold this upside down, am I right? Simply I can bring this one there. So this will be removed from the circuit and that becomes parallel to this one, am I right? This is R1 and this one is R2, right? This is R2 and R1. They two are connected in parallel. Similarly, look at here. These two are connected to ground. Am I right? So what I can do is I can simply, right? I can simply hide this one and connect this one to ground and then connect this one to ground separately. Am I right? Connect this one to ground and these two to ground. So now look at here, this is also ground. Am I right? The bottom line is also ground. So simply I am going to fold this HOE upside down, right? The fold this HOE upside down. So I am going to remove my HOE and then that is going to be here 1 over HOC, right? HOC. Again, I have my HFC into IB. I'm going to do the same. I'm going to fold it upside down, right? I'm going to fold it upside down. Now, remember, now the current direction is from top to bottom. When you are folding it, it becomes, yeah, bottom to top, right? So now I'm going to remove this one and then that becomes, yeah, the current direction will be inverted. This will be HFC into IB, which is this one, right? So my, now I can say that, okay, yeah. Right? So my final circuit is something like this, right? My final circuit is something like this. Right? My final circuit is something like this. So look at here. So R1 and R2 parallel. Am I right? R1 and R2 parallel. Similar to the previous one, R1, R2 have much higher values when compared to RS and HOE. So we can neglect the R1 parallel R2 from the circuit, right? Yes. So this one can also be removed. Right, can also be removed. Right, now I'm going to redraw the circuit, right? I'm not going to do anything wrong. I'm just going to redraw the circuit without these deleted branches, right? So look at here. So the circuit, right? So I have HIC plus minus HRC into V out, right? Look at here. I have my, yeah, I can move this one a bit at this junction, right? So I'll put it here. HFC into IB, and then this is my ground line, and this becomes 1 over HOC, and then this will be my RE, and here I am going to have my V out. This is my V out, and then similarly here I am going to have RS and VS that is connected here, right? So this circuit I have simply redrawn without this one and all the other deleted branches. Clear? So you must know how we can draw this circuit from the equivalent circuit, right? So this is my VS. Now what I can do is as I did earlier, HIE, right? Oops. HOE. All these things are inside the transistor. Am I right? HIC, HRC into V out, HFC into IB, 1 over HOE. All this green box is inside the transistor, and RS, VS, and RE will be the external or externally connected resistors. Okay. Right. So it's 11:51. Do you have class at 12 o'clock today? Hello. Okay, so we can stop with this now, right? We'll stop with the derivation, right? There is a derivation following this one. So yeah, which is also simple, right? So we need to, but we need to continue that one, right? So we cannot stop in the middle. So I'm stopping with this, and we can continue tomorrow, right? Tomorrow at what time you have classes? Hello. Oh, today evening we have class. Do we have class today evening? Yeah, I can stop recording first.